Hello, my name is Mr. Kersey, and I'm here today to talk about temperature and reaction rate. So what you're going to need to successfully do this lab is you're going to need some vinegar. Household vinegar is fine, 5%. Don't need anything fancy. Sodium bicarbonate or baking soda, they're the same thing. Either one is fine. And first thing you want to do is grab a scale, and you're going to weigh out 1.5 grams of your sodium bicarbonate. Okay, once you get that, you would go ahead and place some of that in one of your test tubes. So over here, I've got my test tube. I'm just going to go ahead and pour it in. Now I have already pre-prepared the rest of them so that they all have 1.5 grams of sodium bicarbonate. In addition, you're going to grab your vinegar, and then in a graduated cylinder or some other measurement device, you're going to measure out 15 milliliters. So you will then take that and you would pour it into someplace and have it ready to go. So as you can see here, I've got a test tube. Each of these has 15 milliliters of my vinegar, so it's ready when I need it. So as we mentioned before, the main thing that we're testing in this experiment is how the temperature is going to affect the reaction rate. So this reaction, again, is basically just baking soda and vinegar. It's going to make bubbles. It's going to create a gas, and it's also you'll hear the bubbles popping. So when the reaction is going on, that's what you're going to be looking for. And when the bubbles stop forming and stop popping, that's when you know that you have the reaction is finished. So we have water of varying temperatures. So here I've got water that is basically boiling. And then I have different mixtures of hot and cold water, to where you can see the boiling water is approximately at 95 or 96 degrees. We have the coldest water is at approximately 17 or 16.7 degrees. Our next one is like room temperature, so 26 degrees. We have right around 47, and we got right around 60. So it doesn't matter if they're exactly these same temperatures. The main thing is you just need to make sure you have a variety of temperatures. And then we're going to do one of them. We're going to do the hot one twice, just so that we have a better chance of getting the result, because that one will be the quickest. The other thing you're going to need to have ready is a stopwatch. So I have my phone, which is going to be serving as our stopwatch. So in this case, we want to measure out approximately 15 milliliters of the different temperatures of water. I'm going to be using just a teaspoon to measure it out, so I can quickly just get it into the baking soda and let it dissolve. So what I'm going to do is grab a teaspoon, and again, it doesn't have to be exactly a teaspoon, but you want to make sure it's the same amount of water in each of these. So I'm going to go ahead and just put a teaspoon of water in there, and I'm going to just let this dissolve, kind of mix it up a little bit, and we'll let it dissolve. So then I will do the first two ones are going to be the hot water, and then I'll go progressively colder. All right, so while I'm waiting for that to dissolve, I'm going to go ahead and just record the temperatures. So again, 96 is our water that is almost boiling. So the temperature will be 96. The first two will be 96, so I just put that one in there as well. The next one is going to be We'll just go with 58. The third one, go with 46. 26. And then lastly, 17. All right, so now I've got all my data. Oop, I messed up my data. So 46, 26, 17. Because ultimately we're going to be graphing this in the end, so we're going to be looking at how it relates. But we're going to start off with our one that's 96. So if we have a look here, it has partially dissolved, but is not done yet, but it is good enough for our purposes to continue on. So here again, this is when we're going to be listening for the sound of the bubbles as well as observing them. I'm going to take my pre-measured vinegar and I'm going to go ahead and dump it into one of my tubes. We're going to do one at a time. And then when I dump it, I'm going to start my timer at the same time. All right, so we're going to get ready to do this. So I'm going to go ahead and start my timer as I dump it in. And you can see all the bubbles. And I'm just watching and listening for when they stop. Okay, it has mostly stopped. All right, we'll call that good. So I'm going to go with reaction time of 118.6 seconds. All right, so we're going to reset. And same thing, but for the second one. So we're going to say, here we go, 1, 2, 3. I'm not sure how this is coming up in the video, but you can still clearly hear a lot of the bubbles popping. When we stop hearing it is when we're going to stop the timer. Okay, that's pretty much stopped. We got about 127. So then I'll continue this with the other one. So reset. We're going to go ahead and start the next one. Okay, that's about stopped on that one. So we got about 140.28. And we're going to do the next one. Okay, I stopped hearing it. You end up with 147.24. All right, 2 more. Okay, I stop hearing it now. We end up at approximately 158. And then the last one. All right, I'm no longer hearing that one. All right, so as you can see here, I went ahead and put all of my data into a graph. So if you look at the graph, you can kind of see there is a correlation between the temperature, which is our x-axis, and the reaction time, which is our y-axis. So things to think about in the conclusion questions would be, why it is beneficial to do multiple readings of the same temperature, as well as what this correlation is with your reaction time versus temperature.